This course is based on SunFounder 3-in-1 Arduino kit sold on Amazon. Everything that you learn in this course is included in this kit. The course comes with tons of components and projects, all with instruction and video for smart car and other projects that you can use for school or home automation. You can purchase it from sunfounder.com. The kit also comes with full documentation, code download, learning projects with full explanation, wiring diagram, and the code that you can download. The link to purchase the kit and documentation is below the video in the description. Welcome to Arduino course by Robojax. Hi, welcome to another lecture. In this lecture we are going to learn about the data types and variable and how to use them with Arduino. Data types in Arduino are one of the important aspects of using Arduino efficiently. Arduino stores data based on the type. A reason for that is to use less memory and it will be more efficiently, and also for the reason of security. For example, why should we store 576 and 87,654,321 in the same memory space? So we have a big box that can hold this one, and also in the same big box if we put this one. This will be very inefficient because the box has more space. And memory has exactly the same analogy. We are allocating certain space to store data or information. And the data in Arduino is used based on the type. If you have different length, different type of data, for example, a character, a value with a decimal point, and string of a text, hello world or something, different types are treated as a type of data in Arduino. And to understand that, let's start with a bit. Bit is the smallest piece of data stored and processed. For example, 011001 is a 6-bit data. 8 bits, which bit is written with a small b, is 1 byte. And a byte is written with a capital B. So remember these two, that 1 byte is 8 bits. And the data type that we have is an integer, and we type int to recognize a type of data. And it can represent, for example, 82 or minus 25 or 1200 or 5623, etc. And when you define a data type as an integer, int, you are allocating 16-bit of information. So it will be 2 bytes, 2 times 8, as we mentioned, 1 byte is 8, so 2 bytes, 2 times 8 is 16 bits of space is allocated. This is as if we have a big box with 18 shelves. This is as if we have a big box with 16 shelves. And in those shelves, the value that you store will be as a binary of 0 and 1, and the smallest value that is stored is minus 32,768 to positive 32,767. This is 2 to the power 16 minus 1. 2 to the power 16 will be a value, and then subtract 1. For that reason, we don't have here 68. And if you're using Arduino Duo, instead of 16-bit, we will have 32 bits, which is 4 times 8. So that in Arduino Duo, we can store 4 bytes versus Arduino Uno, which stores 2 bytes. And the value that you can see is very large because the number of bits will be larger. And here, when we define an integer, we type int, and then we type a name for it, and then we put equal sign, and then the value. So this line is assigning 36 to a variable called age of type integer. Very important to pay attention. And when you define a variable, you terminate that line by putting the semicolon. You must put this, otherwise you will get error. And then in this line, we are defining the variable called days as a type integer. What we are assigning is that we get the age here, so we are using the variable. This age means 36. And age times 365. Suppose somebody's age is 36 and we want to find the number of days that person has left. So we have to multiply the age by 365 days, and the result of this calculation will be stored in this variable called days. This equal sign means assign. So we are assigning this value to the variable days. And in this line, we are initializing the serial monitor using serial begin with 9600 baud. Now serial monitor is ready, and then we print this text, serial.print. Inside the quotation, we say age, and because it doesn't have ln, it doesn't create a new line. And in this line, we say print ln. This will create, but we print age. This age, which is 36. So this will print age and 36, and there will be a new line. And then the next line, we see the word days, and then the days, which is the result of this calculation, will be printed. And this one does not print anything except a new line. Let's open the serial monitor. The code has been uploaded. As you can see, it prints this text age with colon and then 36. This 36 is coming from here, and because we have ln, this creates a new line. It goes to the next line, and whatever comes after that will be printed after this, which is here inside the double quote. We print this text days with double quotation, and there is no space in between, and immediately we print this value, which is the result of the calculation from this line. So this has been calculated. Now it's 13,140, and it has been stored here. And this is the multiplication sign. When you multiply one value by the other value, you put this asterisk. And here we have defined another value here as an integer. We say int, and then this is called a variable, and the variable name is temperature. And here we have defined a new value. When we put a value as a binary with 0 and 1, we just put B at the beginning. This is a capital B, and this is stored in this variable temperature. We are using this B to mention that this is a binary. You can store a number either as octal, binary, hexadecimal, doesn't matter, because it is a whole number. It will be assigned to this variable now. And then this line will print B with actual value, and then here it says print ln, and this will print the temperature. That variable, whatever is the value, we will see it. As you can see, it has printed 45. Even though this is not an integer, but because we put B, automatically when you put B, the value is converted into an integer and stores here. And here, this is a hex value that has been assigned to the variable year. 7E3, 0x at the beginning, the same way that we put here B. For this, because this is a hexadecimal value, we put 0x. This is telling this variable that this is a hex value and this is the actual value. And this is actually 2019, stores in the variable year, and then we print this text to remind us what was the original value, and the year is this year that we use. Using the print ln will print it, and this will create a new line, and also this creates extra new line. Value have been uploaded. Let me open the serial monitor, and as you can see, the first value is a text. It is a text, and the second value is a variable which is coming from this, and as you can see, it is printed at 2019, even though I don't have here 2019. The next data type that is used a lot in Arduino is character, and we are typing or representing it at char, C-H-A-R, with lowercase c. This is not capital, lowercase c. Sometimes people pronounce it as char. It refers to character. And we can assign a value like A, lower C, or D to this variable. And it takes 1 byte of data, which means times 8, it will be 8 bits. It occupies 8 bits. When you assign a character, you're creating a box with 8 drawers, and it will occupy that much space. And the value that is stored is from minus 128 to 127. And these are the ASCII characters that we have explained earlier. And here is an example. We are defining a variable called grade of type character, and here we assign A, capital A, and we have single quote. Remember, for character we always put single quotation, and A is assigned to the grade. And here I've created another variable called grade 2. Remember, in variables you cannot have number at the beginning. So grade 2, now 65 is assigned to this. Now if I print this, 9600 baud and grade 2, each will be in a new line. And here is printed A and A. This is the A that I've printed using the grade, and this grade 2 has also printed A. The reason for that is that when you assign A with a single quote of a type character, A is assigned here, but when you assign 65 a number to character type data, it is being converted and it goes and looks at the table and prints it. As you can see, the value of 65 in ASCII table, and in ASCII table A is 65. And for that reason, this A is from ASCII table and we get A. And the next data type that we have is float. This is used extensively. Every time if you want to assign a value of with a decimal point, for example 3.05 or 0.6723 or 145.87, all of these, they have different decimal points. When you have a decimal point, then you have to use float. It occupies 4 bytes, which means 4 times 8, 32 bits of data. This is as if we have a big box with 32 drawers, or a table or a desk with 32 drawers. It can hold from this value, remember, minus 3, this is E plus 38, that means times 10 to the power 38. To this one, as you can see, this is from minus and that goes to plus. And float has some precision for the decimal point. For example, this can only have 6 to 7 decimal points. As you see, it says 6 to 7. I have taken this information from the Arduino website, and the reason for that is because this is the decimal point in digital or in computer is being calculated differently than what we perceive as human, and that is not exact. For example, if you divide in Arduino or in computer 6 divided by 3, you will not get 2, you will get some value. And internally there are extra measures to make this precise, but directly it will not be precise. For that reason, the decimal point is 627, not specific number or value. You will come across another data type called double. Double is another name for float. You can write it with the lowercase d, and this is exactly the same as float. The only difference is that in Arduino DUI, for double, the length is double the float, which is 8 bytes. And then we have double. Double is another name for float. And here is an example. For example, you want to assign 4.35 into variable called price, and the type is float. When you define a variable of type float, you type float with lowercase f like this, and you assign the value as before and terminate the line with semicolon. And the next line I can define 8 as quantity. This is a variable, another variable called quantity, and pay attention, I did not put decimal point, and that is the reason I'm going to show you. And here I have created a new variable called cost, and then the cost is to multiply price. I have taken that price here and then quantity and multiply it using this asterisk and multiply them together, and the value is called cost. We have defined a serial monitor, and then we print this text price and then the actual price that is being printed, so you see what it is printing, and then quantity it and see how it is printed because the type is float. And the next line will print the cost. Let's open the serial monitor, and here you can see this line that prints price, that is good, 4.35, but this line quantity did not print just 8, it printed 0.00. Because of the float, when you assign a value, it also assigns a floating point or decimal points to that variable, and because the floating points are empty, it displays it as 0, 0. And here the cost is the result of the calculation if you multiply those two, and that is the result here. And in Arduino also you can define up to a certain point the number of decimal places. In serial monitor you can put comma and you can put 4. For example, if I put 4 here, you will see that the price will be displayed with 4 decimal places. Here it is displayed at 4 decimal places. We have also another data type called Boolean, and it can be written as bool, B-O-O-L, with lowercase b, or with the full word Boolean with a lowercase b. It is used for true, 1, or for false, 0. And it occupies 1 byte, which is 8 bits of space and memory. Here is how you define it. We type bool or Boolean, full Boolean, and this is my variable equal true. The true and false is also with a lowercase, and these are internally constants. So this true is stored in x and false is stored in b. And if I want to print x, here x and b, let's check it. Here the code has been uploaded. This portion prints this, it prints x, as you can see it has printed 1, and this portion has printed b, and b is 0 because it is false. So remember, true is 1, false is 0. We have another data type in Arduino. It's called string, and it is used to store a text such as hello or I love Arduino, and it occupies 1 byte of space. And here in this example, which I've taken it from Arduino website, I've defined a new variable string type called string1, and the type is string. Pay attention here, it is written with capital S, and I'm assigning this text to this variable, and it's hello string, double quotation at the beginning and double quotation at the end. This will store this string1. This will be stored here in string1, but string is also a function that can accept an input. For example, here we have a as a character. We put single quote around it, and once you do this, we'll get this character and convert it to string, and now I've assigned it to string2. And also this one is another way to assign it in case it comes such as this. So this will be also string. This is converted, and if you need to put, let's say, string3, this portion of the text, with something else, you just put a plus sign and then double quote and another text. Now this text is stitched to this variable, which is this text. So this text will be stitched to this. This is called concatenation. Concatenating is adding 2 texts or stitching 2 texts or 2 portions of data together. And here, if you want to convert, let's say, number 13, you will come across such thing that you want to convert it to string. Just put string and open close parenthesis. Now this is converting it, and now I've assigned it here. I can print this directly, but I'm assigning it to this variable. For the string 6, we have put 45 as an integer, and we say convert it to hex. So this will be converted to hex, and the value will be stored in string 6. And this is treating it as binary, and also this one is a float, and we say the precision is 3 decimal points. So we have to tell how many decimal points, and then it will become a string. And now I'm printing them all one by one. Here, let's run this code. And string 1, here it printed hello string, and string 2, it printed A, and string 3, this is a string. And when we combined these two together, string 3 plus this, it has printed this text for us. And pay attention here, in order to print this double quotation on the screen, I have to put backslash and backslash. This is the escape character, which I have explained it before. And here string 5 has printed 13. This was it. And when we use this type of command, hex 45, it has printed 2D, which means this is an integer, get it and convert it to hex. And here we put 255, and we say it converted to binary, it has printed all 1111. And here, when we say 3 decimal point, it prints this one. But if we mentioned 2 decimal points, and it has been converted, and as you can see, it has been rounded. Another data type that is used extensively is unsigned integer. It can store only positive integers such as 18 or 134. And because we don't have a sign to it, it occupies less space. And in Arduino Mega and Arduino Uno, we have 2 bytes, which means 2 times 8 is 16. Arduino Uno and Mega, the maximum value that you can store is 65,535. And here is an example for the unsigned integer. We define a variable called x of type integer, but we put unsigned. Type unsigned with lower u and space integer, and 456 is assigned into x. And then this is printing the actual value x. And here we use another trick to check the size of it, and it's called size of, and we put any variable you have, it prints it. And let's open it. And here, as you can see, the x has been printed as 456, and then the size of is printed that it is 2 bytes. And another data type that we have in Arduino is called long, and it is written with lowercase l. And for example, if you want to store minus 98 million something or plus 618 million, which cannot be stored in integer, you can use long to store these values from negative to positive, and it occupies 4 bytes. 4 times 8, 32 bits in Arduino Uno. And the lowest number that it can store is this number, minus 2 billion, 147 million. It goes to plus 2 billion, 147 million. And as you can see here, it's 1 number less from the right. And here are other types of data that you might come across, for example, byte, and then we have long, and we have short. And as you can see here, short is 16-bit, so this is 2 bytes of data type. And here another data type is byte, and it is an 8-bit unsigned number. Every time you want to store from 0 to 255, you can use byte. That uses the least amount of memory. And here is also short. Short is 8-bit. That's longer than the previous value, the byte. And we have also unsigned character, because the character can take from minus 255 to 127. Because character can store from minus 128 to 127. Unsigned character can store from 0 to 255. Unsigned character can be used to store value between 0 to 255. And also we have a data type called word. It is 16-bit, which is 2 bytes, and stores from 0 to 65,535. Here, as you can see, the same as unsigned integer. So if you don't want to confuse yourself, use unsigned integer. And then we have array, which needs a little, and then we have a data type here. They mentioned it as an array, which I'm going to explain it when the time. And then we have a data type array, which I will go. And then we have a data type array, which will be explained in the upcoming lectures. Thank you for watching. And here another data type is byte. And it is an 8-bit unsigned number. Every time you want to store from 0 to 255, you can use byte. That uses the least amount of memory. And here is also short. Short is 8-bit. That's longer than the previous value, the byte. And we have also unsigned character, because the character can take from minus 255 to 177. Because character can store from minus 128 to 127. Unsigned character can store from 0 to 255. Unsigned character can be used to store value between 0 to 255. And also we have a data type called word. It is 16-bit, which is 2 bytes, and stores from 0 to 65,535. Here, as you can see, the same as unsigned integer. So if you don't want to confuse yourself, use unsigned integer. And then we have array, which needs a little, and then we have a data type here. They mentioned it as an array, which I'm going to explain it when the time. And then we have a data type array, which I will go. And then we have a data type array, which will be explained in the upcoming lectures. Thank you for watching. And it is an 8-bit unsigned number. To store from 0 to 255, you can use byte. That uses the least amount of memory. And here is also short. Short is 8-bit. That's longer than the previous value, the byte. We have also unsigned character. Character can store from minus 128 to 127. Unsigned character can store from 0 to 255. And also we have a data type called word. It is 16-bit, which is 2 bytes, and stores from 0 to 65,535. Here, as you can see, the same as unsigned integer. And then we have a data type array, which will be explained in the upcoming lectures. Thank you for watching.